Hello and welcome to another tutorial on applying VSEPR theory. This is the third video out of 5 that I'm making, and this one is all about how to deduce the shapes and bond angles for 4-electron domain ions. Okay, so previously I've done molecules, and in my second video I did incomplete octets. This one's all going to be about ions, and there may be some focus on incomplete octets as well. So what you've learned previously may be useful to what we're going to do here. This is useful for anyone doing SL or HLIB chemistry. If you're doing any other post-16 subjects such as A-level, hopefully this will be useful too. So for the IB, the link in the curriculum is exactly the same as the links which I've discussed previously. The big difference with this video is I'm focusing on doing this for ions, okay, which you can see is sort of shown in yellow. So that's what we're going to be focusing on today. Now, in order to remember how to do the procedure for VSEPR, I find it useful to have a good mnemonic. I've changed it slightly based on the mnemonic that I created previously, okay? So what it's now is Dirty Vinny bit my crystal dust early morning, okay? A bit unusual as a mnemonic, and I'll leave it to you to deduce what crystal dust is all about. But the different letters mean these particular things. The D in dirty refers to diagrams. You have to draw a ball and stick diagram first of all, just to get an idea of what's your central atom and what the atoms around it. The V in Vinny is valence electrons. How many valence electrons does your central atom have? The B in bit is bonds. How many single bonds does your central atom make? And the multiple bonds is the mi. So you have to take one away for each multiple bond that your central atom makes, whether it's double or triple. The C in crystal is the charge. So this is a new thing. Whether you have a positive or negative charge, you have to either add or take away from the overall electrons that you have around your central atom. And then the D in dust is divided for electron pairs, and then the E and the M is deducing the electron and the molecular geometry. So very, very familiar to what we've done before. The key change here is charge. Okay, so let's put this in action. So this is my first molecule, it's NH4. All right, so it's kind of the ammonium ion, we call it, useful cation. The first thing I'm going to do is I'm going to draw a diagram. Now, by looking at the formula, I can deduce that nitrogen must be in the middle. So I'm just going to put N there, and I'm just going to put 4 hydrogens around it. So this is my diagram. Not sure about the geometry yet, could have all sorts. We're going to just sort of work it out as we go along. The next thing I'm going to do is valence electrons. So I have to work out the valence electrons around nitrogen. From looking at the periodic table, I know that nitrogen is in group 5, so I'm starting with 5. Okay. I now need to work out the number of bonds. Now if I look at this, I've got 1, 2, 3, 4 bonds around nitrogen, so it's plus 4. Now that equals 9, all right? Now that's a bit unusual because usually if I jump straight to the divide, 9 divided by 2 is 4.5, which doesn't make any sense. So something else must be going on. Multiple bonds isn't something I have to consider here because they're all single bonds. So now I have to think about the charge. Now let's have a look over here. NH4 has got a positive charge. So this number here, this number 9, I have to actually take 1 away from. So 9 take away 1 equals 8. I then do my dust, which is divided for electron pairs. So 8 divided by 2 equals 4 electron pairs. Okay, so now that I've got my electron pairs, I can then go through the stages of electron and molecular geometry. Now first off, for electron geometry, 4 electron pairs must mean that it's tetrahedral. So I'm just going to draw it over here for a bit of space. So here's my nitrogen. 1, 2, 3, 4. Okay, I'm going to put a hydrogen there, hydrogen there, hydrogen there, and a hydrogen there. Now my electron geometry, gone a bit quick there, but my electron geometry is tetrahedral. My molecular geometry is different. Well, it's not different actually, it's a complete lie. Molecular geometry, if I check each electron pair has an atom next to it. So the electron geometry is the same as the molecular geometry. It is also tetrahedral. The final step is to deduce my bond angles. Now my bond angle needs to be somewhere around 109.5 degrees. There are no lone pairs around the nitrogen, and I'll discuss why in a moment, so it has to actually remain as 109.5. The key thing to remember here is when you're drawing these, don't forget to put the brackets and the charge around it to show that it's an ion. Now you're probably thinking, well, hold on a minute, why is it that nitrogen can now do 4 bonds? Because usually nitrogen only needs 3 electrons to be happy. What's going on here is that before this molecule is, well, this ion is made, you have to remove an electron from something. Now a good way of thinking about it is that the hydrogen loses an electron in order to become H+. and then it joins NH3. Now the only way it can do that is if nitrogen donates its electron pair to form the bond. So what you have here is one of the bonds is a coordinate bond, or what we call a dative bond. You don't necessarily have to show the arrow unless they explicitly ask you to. You can if you like, and it's probably a good way of showing your understanding. So that's NH4. Let's try another one. We've now got BF4-. Let's go through the procedure again. The first thing is the diagram. So I've got 4 fluorines around my bromines. I'm just going to do a B and then 4 Fs. I'm not going to worry about drawing the brackets and charge yet, that can happen later. Next step is my valence electrons. Now boron is in group 3, so I start with 3. Next step is a number of bonds, 1, 2, 3, 4, so plus 4 equals 7. Again, an odd number. Multiple bonds, there's no multiple bonds around this, so I can leave that. Next step is the charge. Now look up here, we've got a negative charge. So now what I have to do is I actually have to add 1. So 7 plus 1 equals 8 electrons. I now need to divide for electron pairs. So 8 divided by 2 equals 4 electron pairs. All right. I can now go on to the electron geometry. Now if I've got 4 electron pairs, I'm just going to do it up here again. I've got boron and 1, 2, 3 and 4. So my electron geometry, or EG, must be tetrahedral. The molecular geometry is a little bit different. So my molecular geometry, I've got 4 atoms surrounding it. 1, 2, 3, 4. So actually my molecular geometry is also tetrahedral. And we're just going to finish off with bond angles. My bond angle has to be around 109.5 because the electron geometry is tetrahedral. So 109.5 degrees. And that's it. Remember, just to finish off, we're just going to put brackets and the charge. Again, you might be thinking, boron only has 3 electrons in the outer shell. How is it able to complete its outer shell like this? Well, the way it works is, if you consider BF3, which I covered in a previous video, that has an incomplete octet, and it's actually stable as an incomplete octet. In order for fluorine to bond to it, fluorine has to donate a pair of electrons. Now, because it's a negative charge, this fluorine, which is added to it, is given that extra electron to make it work. So that's how that works. This is an example of another ion. Okay, let's do a couple more. So next one is CH3+, or the cation, which is when you remove a hydrogen off methane. So let's start off with the diagram. So I've got C, H, H, and H. Okay. Next step is my valence electrons. This is carbon. It's in group 4, as I know from this. So I know that I need to have 4 valence electrons around carbon. I now need to work out number of bonds. There are 3 bonds from each hydrogen, so add 3, and I have 7. Again, an odd number. Let's now deal with multiple bonds. There are no multiple bonds. You know hydrogen can only form single bonds anyway, so we can skip that one. And now we're on to charge, which is crystal. So I've got a positive charge here because it's a cation, so I'm going to do 7, take away 1, and that's going to give me 6 electrons. All right. I now need to move on to divide for electron pairs. So 6 divided by 2 equals 3 electron pairs, or electron domains if you like. So I now can work out the electron geometry. So carbon is here. Now it's 3 electron domains. So 1, 2, 3. So my electron geometry has to be trigonal planar. And my molecular geometry, which I'll do later, and my bond angle has to be somewhere around 120 degrees. Now let's work out the molecular geometry. Each of these has to either be a bond to an atom or a lone pair. I've got 3 hydrogens, so I'm going to fill those in. And before I forget, I'm just going to add my charge and my bracket. Okay. And the molecular geometry is exactly the same as my electron geometry. It's also trigonal planar. Okay, bit of a lazy R. So that's the third one. We're going to do one more. Now what we're going to do is H3O+, which is a hydronium ion, I believe. So we're going to start with the diagram. So my diagram, I'm going to draw out as O, H, H, and H. Your first instinct will be to think, oh, this must be trigonal planar. However, let's go into more detail. My valence electrons around oxygen, oxygen's in group 6, has to be 6. It forms 3 bonds, 1 to each hydrogen, so plus 3 equals 9, again an odd number. There are no multiple bonds, remember hydrogen can only form single bonds. So now let's move on to charge. Now, the hydronium ion has a positive charge, so I need to take away 1, which equals 8 electrons. I'm now going to divide for electron pairs. So 8 divided by 2 equals 4 electron pairs. Now let's finish this off. Electron geometry. My oxygen is here. I've got 4 electron pairs to deal with. So it's 1, 2, 3, 4. Okay? Very, very different to what I actually predicted earlier. So my electron geometry is tetrahedral. Just to kind of get ahead on things, my bond angle should be around 109.5, and we'll tweak that a little bit later. Next step, my molecular geometry. Now I've got 3 hydrogens to deal with, so I'm going to put 1 there, 1 there, and 1 there. Okay, which leaves this. Now this has to be a lone pair of electrons if it's not bonded to anything. So I'm just going to put 2 dots there, or if you'd prefer, you can simply rub that off and just put a line there, or 2 dots, whichever you prefer. I'm then going to put my brackets around it, give the charge. Now my molecular geometry is not trigonal planar because it's not in one plane, they've been bent down by this lone pair. So instead it's trigonal pyramidal. Okay? And because it's only one lone pair, I put 1 inequality sign. And we're done. So I hope this tutorial has been useful. If you're doing HL, please watch the follow-up videos number 4 and 5.